If we're looking at a constructed confidence interval, we might be curious how much error was allowed in the building of the confidence interval. So if we want to determine the error in the interval, we have a couple of techniques we can use. If we happen to know the point estimate, the center of the interval, we can calculate the error by looking at the difference between the point estimate and each of the boundaries. So if the point estimate is known, we can calculate the error by taking the difference from the upper boundary to the point estimate, or we can use the point estimate, subtract the lower boundary. Both of those would give us the same calculation, the same error. But let's say we don't know the point estimate. We can still find the error in the interval by considering the total length of the interval. If I take the total length of the interval, I know I'm looking at twice the amount of error. So if I can find the length of the interval, I just need to split it in half, and that would be equal to the error. To find the length of the interval, I'm going to imagine each of the boundaries as arrows that are the length of each boundary. So the lower bound would have a small arrow, and the upper bound would have a longer arrow, since that's the larger number. To find the length of the interval, I'm trying to find the difference in the lengths of those two arrows. So I would do the long arrow subtract the little arrow to find the length of the interval. And we know that the length of the interval is 2 times the value of the error, so I just need to split that in half. So to find the error, I'll do the difference from the upper to the lower boundary to find the length of the interval, and then divide it by 2. Another question we might ask ourselves while looking at a confidence interval is, where is the center? If we don't know the point estimate, but all we can see is the lower bound and upper bound, we might be curious, where is the center? To find that, we're really just looking for the average between the lower bound and the upper bound number. To visualize that, I'm going to again bring back those arrows, small arrow for the lower bound, long arrow for the upper bound. To find the average of these two numbers, we add them together to find the total of the two numbers, and then we need to split it in half. We're looking for the halfway mark from that full length of the two arrows combined. In other words, we're looking for an arrow that would make it halfway across. That's the center. So to find the center, we're going to add together the upper and the lower bound and divide by 2. Notice here that we've got two formulas that look very similar. The error and the center calculations both involve very similar calculations. But notice that in the error we're doing the difference between the boundaries so that we can find the length of the interval, and when we're calculating the center, we're adding the two boundaries so that we can find the average of the interval. Let's put these two formulas to use. We're looking at a confidence interval with a lower boundary of 67.18 and an upper boundary of 68.82. If we want to find the error, I need to find the difference between the two boundaries and divide by 2. We find the error to be 0.82. To find the center, I'm going to find the sum of the two boundaries and divide by 2. The center comes out to be 68. And we can double check our work. If we take that center, 68, and we add the error back to it, we get 68.82, which is our upper bound. If we took the 68 and we subtracted the error, we would get 67.18, the lower bound. So we can check our work here to make sure that the error and the center that we found do in fact recreate the confidence interval that we started with.